Today we're going to start with the basic ideas of geometry. Now, you may not know this, but there's more than one system of geometry out there. I know of 4, and I think there are some other ones. The one that we study is the most ancient one, or started the earliest. It's called Euclidean geometry or plane geometry. It's not important that you know that, but that's what it's called. All of those systems, by the way, one of them that you may be at least somewhat familiar with is spherical geometry. All of that's how global positioning works, because the Earth is basically a sphere. So all the stuff that's done on the globe, that's all done through spherical geometry, which is different. So every system of geometry is based on a few basic undefined terms, which are given meanings by postulates. A postulate is just this statement that you make that's accepted as true to get you started without any kind of proof. Okay? You have a few basic things where it's like, these are the things that we believe in for this kind of geometry, and then we build everything else up from there. It's the same, honestly, with you. There are a few things that you believe in, and those things shape how you respond to the different things that happen to you during your life. Okay? So if you think about it, like if you have someone, you may know someone who, we used to call them an Eeyore, who's always, everything is bad, if it's good now, it's going to get worse. All that. So how do they respond to things? That what they believe colors how they respond, and that's true for everybody. Well, that's true for geometry also. What we start and say, this is what we're going to believe in for this kind of geometry, is going to affect everything that we build up from there. Okay, so the 3 undefined terms are, for our geometry, are point, line, and plane. You already have lots of experiences with points, lines, and planes. Why? Because you've already taken algebra and you graphed a lot of lines by putting some dots on a piece of paper, which represented points, connecting them with a straight line, and you did it on a piece of paper, which represents a plane. Ta-da! That's points, lines, and planes in a nutshell. Now, what do these basic postulates say? Well, the first one says that through any 2 points, there is exactly one line. So to represent a point, we just put a dot. And if I put 2 dots like this, how many lines can I draw through those 2 points?
1.
Just 1. Why is that?
Because there's no other points.
Well, are there not any other points? Or just I haven't drawn them? I just haven't drawn them. There's a whole bunch of other points. Might look like this, for example. We'll name those points A and B. Typically with points, we use capital letters to name them. And a point is just represented by a little dot. So why can I only draw 1 line through those 2 points? What is it about a line that makes that true?
Can only go one way. I mean, like it doesn't curve.
Okay, it doesn't curve, and that's the main part, okay? It doesn't curve. In spherical geometry, your lines are on the surface of the sphere, and so they all curve. In fact, if you talk about like the North and South Pole as being 2 points, you could draw an infinite number of circles that would go through those, and those circles are your lines, right? It's a straight path. but because it's on a curved surface, it changes it. Okay? So this assures us that the quality that it gives us is that lines are straight. This is sometimes called the straight line postulate. Through any 2 points, there's exactly one line. So for this class, and anyone who's had my class before will tell you, yeah, if you say straight line, Mr. Davis will make fun of you. Because for this class, lines are straight. There is no such thing as a non-straight line for this class. Now, could you define line a different way? Yeah. Right? Like in art, you're like, you want to make these, these little lines, and it's like, okay, well, those are marks, but for geometry, those aren't lines. Okay? All right. Now, what about planes? Through any 3 points, not all on the same line, there is exactly one plane. So if I put a point here, and a point here, and a point here, it says 3 points, not all on the same line. If I just connected those, what kind of a figure do I get?
A triangle.
A triangle. And there are lots of characteristics of a triangle, but one of the essential characteristics of a triangle is it's flat. It's not three-dimensional, is it? So if I draw 3 points, and it doesn't have to all be, I drew those 3 points on my piece of paper, but it doesn't have to be on the piece of paper. If I do 1 point is up here on the top of the TV, and another point is there at the Apple TV, and another point is over there on the ceiling, if I connected those, do they make a nice flat surface?
Yeah.
If I was to take a string and go from the corner of the TV here to the Apple TV thing here to that point right up there where the two things meet, right up above me. If I was to connect those with pieces of string and pull them tight, would that create kind of a flat surface?
Yes.
Yeah. Because if I, colored that in, it would make a triangle, and a triangle is nice and flat. So this is sometimes called the flat plane postulate. Planes are flat. And if 2 points lie on a plane, then the line containing those points also lies on the plane. This is true, by the way, in spherical geometry also. If you put 2 points on a globe and you connect them with a straight path, that path is also going to be on the globe, right?
Right.
So, let's talk about how we represented these. We've already talked about it a little bit. A point is represented by a dot and a capital letter. Always by a dot, always by a capital letter, never a lowercase letter. Okay? A line is represented by a straight path with arrows at both ends. The arrows show that those go on forever. Now, I don't know in algebra if your algebra teacher ever got on you when you were graphing lines if you didn't put arrows on the ends, but you should, because those lines kept going infinitely. Now, I don't know what the heck that is, but let's change that to look like that. So, to name a line, one of the ways we can do it is if we have a lowercase cursive letter. or if it's in your textbook, it's an italicized letter, but it has to be lowercase. That's near one of the arrows. We can name the line that way. We can call it line L. You can also name the line by any 2 points on the line, because how many lines go through both K and L?
One.
It's just one. So I could call this line KL, and that includes point M. I don't have to name point M. If I say line KL, that includes all of this. Or switch it around, LK. The order is unimportant, right? Or LM, or ML, or KM, or MK. Any of those are fine. All of those name the line. We will only name 2. Right? Some people are like, well, why can't I just name all the points that have names on them? And I'm like, because it's unnecessary. And it's not really a joke, but I kind of make fun of it. Mathematicians are either, depending on your viewpoint, the most efficient people in the world or the laziest. They're like, why should I name all 3 points when 2 is enough? Okay? And they're like that about most things. So points K, L, and M, these 3 are called collinear. Yes, I know it looks like it should be pronounced collinear because of the double L. I don't know why it's spelled this way. English spelling doesn't make any sense at all. You frequently just have to kind of go, okay, and memorize things. It really should just be a single L. I don't know why it's a double L. But those are called collinear points. The co in that means the same. Linear, line. Same line. They're all on the same line. They're all contained on the same line. Points P, K, and L are non-collinear. Are P, K, and L all contained on the same line?
No.
No, they are non-collinear. Question, what about points P and M? Collinear or non-collinear? Discuss it with the person sitting closest to you. Go. That wasn't a discussion, that was a word. Discuss. Do you believe they are or not? Now, frequently I will do this, not all the time, but frequently when I let you discuss something, I will ask someone to share, and you don't have to share what you said. You can say, when we were talking about it, someone said, and that way, if it's wrong, it wasn't you. Okay? It's a technique I learned years ago where it's like, you can just say, well, in my group, someone said, and if they're wrong, you don't worry about it. Okay? So, would anyone like to share your group? Yes, Abby.
So, someone from my group said that it was non-collinear because the P is not in the same line as the M, and it's trying to be different, and everyone hates the P, so that's why it's like somewhere else and not in the line.
Yeah, someone in my group said that too.
Excellent. Any other thoughts?
I think that covered it.
I think someone agrees.
All right. Well, the people in your groups got them wrong. P and M are collinear.
Dude.
Let's go back up to our very first postulate. Through any 2 points, there is, whether it's drawn there or not, exactly one line. So, what do you think? Do you think P and M are on the same line?
Yes.
Yeah. Does it matter that it's not drawn? No. So they are collinear. They're both on line PM, even though PM isn't drawn. Yes, ma'am.
So if you have 2 points, they're always going to be collinear.
Right, but if you have 3, then it's
There's a
not.
chance.
Well, there's 50-50, I guess.
Well, I don't even know if it's 50-50, but yeah, when it's 3 or more, you don't know. Right? If it's only 2 points, you don't even have to bother looking at the diagram. If you've got 2 points, you can draw a line through them. They're collinear. That's exactly right. Well said. All right. How do we represent a plane? Well, although with what we did earlier, you could represent a plane with a triangle. Typically, it's represented by a parallelogram, like so. The way that you name the plane is with a capital cursive letter. This is plane R. It's the easiest way to name it. But you could also name it by naming 3, and it's always 3, non-collinear points. You can also name the plane by naming any 3 non-collinear points that are on the plane. Now, someone may ask, well, why does it have to be 3? It's a perfectly good question. Let me show you why it has to be 3 and why they have to be non-collinear. So, let's say that the front of this screen is a plane, right? It's nice and flat. If I just tried to name this plane BC, is there not another plane that goes like this, that goes through B and C?
Yeah.
Yeah. So if I name this plane BC, no one knows whether you're talking about this plane that's drawn here or this plane here that's coming out of the screen towards you, or this plane that's coming out of the screen but at a different angle. In fact, there are a whole bunch of them. But once I do A, B, and C, can I do this nonsense anymore?
No.
No. It has to be flat, right? It has to be on that plane. So that's why it has to be 3 non-collinear points when you name a plane, if you're not naming it with a capital script letter. All right, any questions about that? Okay, another term that you'll need to know is a segment. A segment is a part of a line containing 2 points, called the endpoints, and all the points between them. So here, this is segment JK or segment KJ. The order is not important. It doesn't go right to left or left to right. Does not matter. Some older textbooks will actually put like dots at the end of this. You're welcome to do that if you want, but you certainly don't need to. Then another part of a line is called a ray. A ray is a part of a line that starts at an endpoint and extends infinitely in one direction. So here, this is a ray. It's a little bit like you drew a line and you erased one side of it. Okay? It's everything on one side of a point on a line. Now, when we name these, you must name the endpoint first. And even if the ray points to the left, the symbol always points to the right, because in English, we read from left to right. Now, occasionally I get students who go, and you don't need to write this down if you don't want to, but let's say that I have an array that looks like this. It's got 3 points on it. When I name it, the first letter has to be S. It doesn't matter which of the other ones you write next. I could call that ray SR or ray SP. It's the same set of points. Okay? And we went through that really quickly, but are there any questions about that? All right, then your assignment is, I believe, in the book. So if you will, you can check on RenWeb, you can get out your computer and get started, because you do have some time.